Hello, welcome. In this video, let us look at how to solve absolute value inequality of type O. When we solve absolute value inequality, we combine two ideas, solving absolute value equation and writing the answer to the inequality in either set builder or the interval notation. Here is an example. 3 plus absolute value x plus 2 minus 3 greater or equal to 9. There is two steps to this process. First step is we solve for the absolute value symbol itself. So let's do that now. Here is the inequality. To get absolute value by itself, we need to undo minus 3 and times by 3. Following the order of operations in reverse, we undo minus 3 first. And to do it, we add 3 to both sides, which makes plus 3 plus 3. So 3 absolute value x plus 2 is now greater or equal to 12. Now we need to undo multiplication by 3. To cancel times by 3, we divide both sides by 3. And because we are dividing by positive 3, not negative 3, the inequality symbol does not change. 3's cancel off, and 3 goes into 12 4 times, which now gives us x plus 2 is greater or equal to 4. Now we split the inequality into two parts. The first part is we know that absolute value is always positive. So whether this inside comes out to be positive or negative, absolute value will make it a plus. So we're looking for all the answers that will satisfy both positive and negative output. So let's find all the answers that make the x plus 2 positive. So all we need to do is find all the answers that make x plus 2 greater or equal to 4, meaning all we need to do is just ignore the absolute value symbols or drop the absolute value symbols and solve the original inequality. All we do is minus 2 from both sides, and that makes x greater or equal to positive 2. The second half could have come up to be negative on the inside, and taking the absolute value of that negative would make it a plus, which would still give us the answers that would work for our inequality. So let's solve this half as well. Now, to cancel the negative 1, we can divide both sides by negative 1. So let's do that. Dividing both sides of our inequality by negative 1 will cancel the minus, but it will also switch the inequality symbol. And that makes x plus 2 less than or equal to negative 4. This is why when we split the inequality into two parts, there is always first half, which is the original, and the second half has the opposite inequality symbol and the opposite sign on the number, because that comes from dividing both sides by negative 1, and dividing by negative 1 switches the inequality symbol and switches the sign of a number. So all we are doing is we're simply not writing this step and going straight to this step when we split the inequality. So let's finish this answer. All we need to do is minus 2 from both sides. That makes x less than or equal to negative 6. Now we have our two solutions, and we need to write the final answer. There are two possibilities, and or, depending on the original inequality symbol. The and comes from the less than, the or comes from the greater than. We have greater than, which means our answer is going to be of the type or. And the final answer for the or is everything that is shaded, because we are asking for all the answers that were true for either the first inequality or the second, which means there is two halves to our answer. Let's write each one. So for x greater or equal to 2, here is 2. Greater or equal is everything to the right. And because we have an equal with our inequality, we get a bracket. Negative 6 is right here. Everything less than is to the left. Once again, bracket. The interval notation describes where these answers begin and where they end. They begin all the way to the left with negative infinity. They end all the way to the right with plus infinity. So in the interval notation, we will get parentheses, negative infinity, comma, negative 6, close bracket. Then there is a union symbol, which simply means there is another piece to this answer. And the second piece is bracket 2, comma, plus infinity, So that's the answer in the interval notation. In set builder notation, we begin with the curly parentheses. Our variable is x, such that, and then we write this condition exactly as it is, such that x is greater or equal to 2, or x less than or equal to negative 6, close curly parentheses, and that's the answer to our absolute value inequality in the set builder notation. And this is it for this video. If you have any questions on anything, please let me know. If you have some of your own questions you would like to see discussed, also let me know. Thank you for your time. Look forward to hearing from you.